Hi, my name is Robert Levy. I'm the CTO of Conductr here from the Wearable Technology Conference in Munich. We are here to demonstrate the technology of Conductr. What Conductr is a web service framework that enables application developers to build user experiences that span across multiple devices and multiple platforms. So the problem that we see today in a lot of applications is fragmentation. Developers have to deal with all the types of differences that exist between tablets and phones and different models and OS versions and things like that. And we found that wearables really compound that problem, where now you've got different types of watches with different limitations and capabilities, different types of glasses, different operating systems, things like that. So the way these problems often get solved is through simply duplicating the same type of functionality across all devices. So we'll take email, for example. When you get a new email, if you happen to be using a smartwatch and glasses and a phone and a laptop or a tablet, every single one of these things is going to give you a notification at the exact same time. They're all going to ping and vibrate and really demand your attention to come in and dismiss those notifications. We think this is the wrong user experience. We've also been involved in the multi-screen application environment for quite a while. And what often happens there is two types of environments. Either an application where the content just gets duplicated. We take whatever video is showing on my phone or tablet and beam that exact same video, copy the screen over onto a television, or we see things where there's tight coupling between two specific models of devices, like a specific watch with a specific phone or a specific TV with a specific tablet. We think that's also, those are good user experiences for those specific devices, but ideally for end users, things are more cross-platform and flexible than that, to be able to handle any number of devices, any combinations, any platforms. And that's what Conductr tries to solve. So an application configures our service with the different capabilities of the application and what characteristics of devices are most important to each of those application features. And then our platform will help the application put the best feature on each device that happens to be connected at any given time. So for example, here we've got this PowerPoint type of application where we've got the slide list, some speaker notes, and a timer down at the bottom. If I connect in, sign into the same application on my mobile phone, then what we'll see happen as I sign in is that the slide list, the speaker notes, and the timer will jump over to my phone off of the laptop. And this happens not because the application was coded specifically to say that these features should appear on the phone and the current slide should appear on the laptop. In fact, the way the application was set up is to say it happens to have a feature that is the current slide. The current slide would like to be on the largest screen available, and it would like to be by itself. And based on that, our algorithms figured out, okay, here's the two available devices. This one's optimal for the current slide. Everything else can go here. It gets more complicated, though, when you have a larger number of devices or more variety of devices. So, for example, down here, I've got the slide timer on my phone, which is neat. That's a good thing to have on my phone when it's acting as a remote control. But if I happen to have a smartwatch, we can run the Conductr application on the smartwatch, and we'll see the timer jump off of my phone and onto the watch. So now on my watch, it's telling me what slide number I'm on, how long we've been on the current slide, how long the presentation's been going in total. And it's not a dumb display. Just like we can control the slides from the phone as a remote control, we can actually push the buttons on the watch and have it update what slide we're on across all of these devices, move forwards and backwards. We can actually go farther than that. I can add in my glasses. And if I connect into the same application, I've logged into my glasses, what we'll see happen is that the speaker notes will disappear from the phone, and the speaker notes will then appear directly on my glasses. So I have a nice private teleprompter in my peripheral vision. So now what we've seen is that the speaker notes have disappeared from my phone and appeared on my Google Glasses. And from the glasses, I can also tap to bring up the menu, to move forward and backwards from the slides, or even ask it to read the slide notes out loud to me. This didn't happen, again, because the application developer coded anything specific to the glasses. The application developer didn't necessarily even know the glasses existed. It's that they were using our abstraction layer to define what attributes of device are best for each given feature, and the description of those features in a way that we can translate to being rendered on each of these different types of wearable devices. So this is powered by cloud-based web services so that it can be used from any type of device. We've also got some interesting capabilities, such as the ability for other users to connect into the exact same session. So I happen to be logged in using the same account on all of these devices. Here's another device that I haven't logged in on. So this will be a guest. This guest can scan a QR code, and as a guest, will be connected into the exact same session automatically, but we'll get different types of capabilities. So rather than being able to change slides or see speaker notes or anything like that, what we'll see is, here's the slide. This particular slide happens to have a graph on it, but it's kind of a ambiguous graph. It's difficult to read. It would be interesting if we can take advantage of the fact that we have multiple screens in use concurrently, so that I, as a guest in this presentation now, can tab over and see the raw data that's been extracted from this PowerPoint slide. And on this data, I could search or filter or sort and really do my own analysis of the information that's being presented by the speaker. So that, in a nutshell, is what we're building at Conductr. Thanks.